Today we're going to talk about proportions. So first, what the heck is a proportion? A proportion is two fractions that are equal. For example, the fraction 1 over 2, 1/2, is equal to 4 over 8. This whole thing is a proportion. So sometimes we will have an unknown in a proportion. So, for example, 7/12 is equal to some unknown number over 4. How do we solve for that unknown? And the answer is very simple. Cross, multiply. Okay? You literally go across and you multiply those two numbers. 7 times 4 is 28. Now we do the other one. We go across and multiply those two numbers. 12 times x is 12x. And we always put an equals in the middle. Now we have a much easier equation to solve. To solve this equation, we divide by 12 on both sides. And we end up with x equals 28 divided by 12 is 2 and 4/12, which reduces to 2 1/3. It's that easy.
Hello. Elevator had a little bump there today. As you know, today we are talking about proportions. And today, my version of the proportions, we're going to be talking about proportions with percents. So Patrick preaches proportions with percents. That's an alliteration, your connection to English for the day. Whenever we do proportions with percents, we look at the part of the whole and the percent over 100. So that's the formula that helps us remember where to put everything. And the key to this whole thing is, like an equivalent fraction, these are going to be equal to each other. So, if the question was, 16 is what percent of 64, we look at our wonderful helper equation here, and we look at the part, which is 16, and there's our fraction, and here's the other part of the fraction, and there's our 100%, our equal sign. 16 is what percent, so we put our question mark here with our percent sign, of 64. And that's when we take out our trusty calculators, or we multiply, we cross multiply 16 times 100, which is 1600. We put our little sign here to remember. And then we take 1600 and we divide it by 64. And 1600 divided by 64 for long division is 2, that's 128. 2, that's 3, 320, that's 5, that's 320, 0. And so our 16 over 64 becomes 25 over 100. And that is how you set up the equation of a percentage problem. And now we're going to take it to Withers. Hey, Withers.
All right, so the last thing that we want to look at is figuring out, sometimes we have percent proportions and we have story problems and we have things where we need to use proportions in a scenario that's not set up exactly perfect. We might have a situation like, in my class I have 3 girls and 2 boys. So I could set up a fraction of, I have 3 girls for every 5 total students. I'm going to put TS for total students. And I might set that up as a fraction. And then maybe Mr. Garland or Mr. Lichty says, well, I have the same ratio or the same proportion as you, Mr. Withers, but I have 20 students in my class. So we would put 20 total students on the bottom. Now notice the key with this, I don't have 100 like a nice percentage like Mr. Garland had, and I have a story problem where I have to set this up. And so the key that I want to make sure that I remember is I'm always putting the same things in the same places. So with my original fraction, I had said girls on the top of the fraction, total students on the bottom. So with my second fraction, I know that if I have 20 total students, that has to go on the bottom because I've already decided that those are the bottom of the fractions. I have to keep those things straight. Now that I have this and I'm looking for the number of girls, I can do cross multiplication like Mr. Lichty and Mr. Garland did. 20 times 3 is 60, and I set that equal to 5g. And then I just need to divide by 5 on both sides of my equation to solve, and that would tell me that there are 12 girls in this class of 20. Now, if you use Mr. Garland's strategy of multiplying across and dividing by whatever number we didn't use, you're going to get the exact same thing. Now, remembering that we have to always set things up with the same things in the same places, just realize that even if you set this up totally different than I did, and maybe you said 5 total students and 3 girls, and had that on top, and that's totally fine. When we set up our second fraction then, 20 total students would need to go on the top because total is on top, and girls that we're looking for on the bottom, same thing's gonna end up happening. 20 times the 3, and I'm gonna end up dividing by the 5. I'm still gonna get 12 girls as my answer. So no matter how you choose to set up your equations, doesn't really matter as long as we keep the same things in the same places. Hopefully that makes a little bit more sense about proportions and percents and setting those up today. And if you have questions, feel free to ask us. Proportions, easy as pie. First time we shot that.